All right, welcome to lesson 7. This is rotations and rotation symmetry. So if you're checking this out at home, I don't know if you can kind of see this. I just cut up a page protector. You could really use any sort of clear plastic. You can use tracing paper. And I also have a whiteboard marker. You can use a thicker one too. That's fine, but this one's a little bit more precise for what we're going to do. So we're talking about rotations and rotation symmetry. So a rotation is a transformation in which a figure is turned or rotated about a specific point. To rotate it, an object and find its image, you must know the amount, 90 degrees, 180 degrees, and the direction of rotation. So clockwise goes that way, and counterclockwise goes the other way. Okay, there's 360 degrees in one full rotation. That means to go halfway would be 180 degrees, and a quarter of the way would be a 90-degree rotation. And this could be clockwise or counterclockwise, it doesn't really matter. Okay, so a rotation, so we need to know the points, we need to know the direction, and you also need to know the center of rotation or turn center, the point about which the rotation takes place. So let's perform the following rotation. So ABC has vertices 0, 0, which is the origin, okay, and 3, 0, so we can label that B, we could call that A, and we can call this C. Perfect, okay. Draw the rotation image of ABC and label it appropriately. So we need to rotate it 90 degrees counterclockwise, which means that this is going to rotate that way. Now this can be a little bit confusing, so this is where our little tracing paper or plastic sheet comes in handy. So what you need to do is you need to put your plastic sheet on top of this, like that, and here's what I want you to do. I want you to first trace the axes, okay? Then I want you to trace your image. You don't have to shade it in, it's just going to be useful when we rotate it. Okay, so 90 degrees counterclockwise, we got to rotate it that way. So what we're going to do is we're going to rotate it until the axes line up again. That is a 90-degree rotation. So what we need to do now is take our pencil and put little dots where the vertices happen. Just double check. Yeah, that looks good. So there's our rotation. You can take your paper off now and connect your points. There you go. Now back to the original. What we can also do is label what the points are. So this was C, this is B, and this is A. So watch what happens when it rotates. Where does C end up? Well, it's way over here. So this is going to be C prime. A prime stays in the same spot, and B prime goes there. Now the other thing you could do is you could rotate it kind of the opposite way that you did, and if you disregard that, it looks kind of like the original, right? Okay. So you'll notice that the lengths of the sides are unchanged, the measure of the angle are unchanged, the orientation of the figure is unchanged, the rotation image is congruent, and each point and the rotation image are the same distance from the center of rotation. What that means is like B is 3 away here, or the B prime, and B is also the same distance away here. Okay? Let's try another one. Plot RST with vertices -5, 0, -1, 0, and -2, -3. So R is at -5, 0. So that's going to be over here, 1, 2, 3, 4, 5. There we go, there's R. S is at -1, 0. All right. And T is at -2, 3. So -2 and then -3, sorry, 1, 2, 3. So T ends up there, okay? And it's a triangle, So we definitely do connect the points. Okay. Trying to be as accurate as possible. There we go. There's RST. So what do we have to do with this image? Well, we're going to rotate it 180 degrees clockwise. So that means 180 degrees in that direction. So let's grab our little marker again and our piece of plastic. First, trace the axes. Okay. And you're going to trace your point, or sorry, your triangle, and you can even label your points, R, S, and T. Okay, so 180 degree rotation clockwise. If we rotate it till the axes line up again, keeping that center point with the origin on the origin, I should say, that's only 90 degrees. So we actually need to do it once more, and that's going to be 180 degree rotation. So you need to grab your pencil, and you might have to do a little flip in here, but S appears to be right there. R is right at the end of the arrow, and T, we need to go right there. So T is going to be there. And we can go ahead and connect those points. So this is T prime, this is S prime, and this is R prime. Now we need to come up with the coordinates of each point. So S prime is going to be at 1, 0. R prime is at 5, 0. And T prime is at -2, 2 and +3. If you're looking at home or watching this in class or whatever you're doing, notice that -5 went to 5, +5. 0 stayed 0 because it's on the origin. -1 went to +1, 0 stayed 0. -2 went to +2, and -3 went to +3. Okay. Shall we try another example here? So ABC has vertices A, 3, 7, 9, 4, and 6, 9. So let's plot these points. So A's at 3, 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So that's A. And B is at 9, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Okay, and C is at 6, 9. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that looks correct. Let's check my answer key at home. Yep. All right, now this one's tricky. The last two have been rotated around the origin, but this one is being rotated around some other point. But don't worry, we got our sheet of plastic, we got our pen. Again, tracing paper works as well. So what I want you to do is trace the shape to begin with. That's not a very good job. Like I say, try and be as precise as possible, because the smaller the grid, it's easy to get the wrong point. Okay, so you got to keep this sort of pressed down so you're not letting it slip. If you let it slip, reline it up as best you can. Okay, so we're not rotating around the origin, we're rotating around point -4, 3. Well, where the heck is -4, 3? So -4, 3 is 1, 2, 3, 4, and 1, 2, 3. So we got to rotate it around that point. So instead of tracing the, actually I'm just going to do a firm dot here. 1, 2, yeah, -4, 3. Okay, so this is our point M that we're rotating. Okay, I'm just going to put a little sort of crosshairs there. So you'll see that I've put a dot right where point M is. And what I want you to do is do a little crosshairs there, and I'll show you why. So we have to rotate it around point M. So instead of the origin, where you'd line it up sort of with the origin, you're lining up your little crosshairs with your point M. Now we want to rotate it 90 degrees clockwise. So we're going to rotate it around this way. So clockwise, that is a 90-degree rotation clockwise. Okay? It starts all lined up and rotate until your crosshairs line up again. Boom. Okay? And here's where you kind of have to flip back and forth. Let's figure out, looks like A prime. Looks like one there, and looks like one there. Okay. Now, you can also A, C, and B. So when we rotate it, where do those points end up? Well, A is at the top here, so A prime, and C prime, and B prime. So now our last step is to figure out the coordinates of this. So A is going to be at 0, -4. B is at -2. -2? No, -3. And looks like -10. Hold on. 2, 1, 2, 3, 4, 5, 6, 7. So C is at 2, -7. And B is at -3, -10. I think I got that right. Let's just double check. ACB, we're rotating 90 degrees. ACB, perfect. Okay, so we got another page here. Quadrilateral. Let's get that out of the way. Quadrilateral ABCD has vertices -3, 1. So -3, 1. -2, 2. Three, 3. Weird shape. And D is at 1, -1. Okay, so it's a quadrilateral, so I know that I can then connect my points. All right. And here's what we're going to do. So put your little piece of plastic over top, and we are rotating it around point D. Okay, so point D is our point of rotation. So instead of tracing the X and Y axis, I want you to put, maybe I should use another color here. Okay. Put a set of axes through point D. And this will just help you with how far to rotate it. Okay. So we're rotating it 180 degrees clockwise. So if we rotate it once, that's a 90-degree rotation. So we need to do it once more. And we end up, remembering to keep our little crosshairs around the point of rotation, and there it is. So it looks like we got a point there, we got one there, way down here, and point D stays the same because that's our point of rotation. So we can connect these lines up, and we have ourselves a 180-degree rotation. So we also need to figure out that's C prime. D prime stays the same. So that's nice. We can just leave that as 1, -1. Okay. B prime is going to be this one. And A prime ends up being there. Sweet. So A prime is going to be at 1, 2, 3, 4, 5 for our X. And 1, 2, 3, -3 for our Y. B prime is going to be at -4, or 4, and -4. And C prime is at -1 and -5. Awesome. Okay, rotational symmetry. A shape has rotational symmetry when it can be turned less than 360 degrees about its center to match itself exactly. The number of matches in a complete rotation is called the order of rotation. The smallest angle you need to turn for two shapes to match is the angle of rotation. Therefore, the angle of rotation is 360 degrees divided by the number you come up with. So here's how you can figure this out. Just trace your shape like that. Okay, and I'm just going to put a little dot at the top, and I'll kind of show you why. So we're going to rotate it. Doesn't matter which way you rotate it, but that's 1. Okay, it lines up again. 2, 3, and back to the beginning is 4. So this one rotates 4 times. So you'd go 360 divided by 4 is 90 degrees. Okay, so the star matches 4 times. So the star has rotational symmetry of order 4, and the angle of rotation is 90 degrees. Nice. Okay, let's try this other shape here. You don't have to be like perfect with these, but it does help to be somewhat neat. Okay, again, I just put a dot at the top, so I start counting, and I count until the dot ends up back at the top. So, does that match? Yep, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this bad boy has rotational symmetry of order 8 and an angle of rotation. Well, here's where you got to go 360 divided by 4, and you're going to get 45 degrees. So every 45 degrees that it rotates, it ends up being in the same spot. Okay, find the order and angle of rotation, symmetry for these shapes. So where can we start? Let's start when it lines up back at this corner here. Okay, so 1, 2, 3, 4, 5, 6. So the order of rotation is 6, and the angle is going to be 360 divided by 6, which is 60 degrees. Okay. All right, 2 more. That does not match. That does, so 1 doesn't match. That does, so twice. So the order of rotation 2, and then we go 360 divided by 2 is 180 degrees. So every 180 degrees, it looks the same. And the last one, you can probably guess. Go real quick. It looks the same when it's inverted. Whoops, you can't even see that, sorry. Looks the same when it's inverted and when it's vertical. So this is 2. So 360 divided by 2 is 180. So the angle of rotational symmetry is 180.